Hello everyone, my name is Vikas and this is one more session from Tutorials Diary on Solidity. So we already talked about some of the features which we have in Solidity in the previous videos. So in case you haven't gone through, I would recommend you to go through that videos and that will make you aware about the features which we have in Solidity and how you can work upon that one. So in this session, we are going to talk about very important portion of Solidity, which talk about that how you can send the ether in the Solidity and how many ways you have currently in the Solidity which you can use to transfer the ethers basically. So this is how we generally ask the questions how I can send the ethers. So how many ways I have and how I can transfer the ethers. So ether is nothing but money, right? So we all aware. So ether like the bitcoins, so same way we have ethers, and you're already aware that you can transfer the ether between the accounts which you can use using wallets. And second thing is that the contract which you have, it can also store the ethers in there. Not only account, the contract account can also store the ethers. So we're going to talk about the contract accounts here, which and how you can transfer the ether from remix ID to some smart contract. Okay, so this is what the topic which we have in this session, and we'll talk about that one. So let's see. First of all, we'll go with theory part. Let me explain you the concepts which we have behind this one. Then we'll jump to the hands-on. So you can send the ether by three ways in the Solidity using the send function, transfer, and call function. So always remember that you should use the transfer function always. We'll talk about why we are asking you to recommend why we are asking you to use transfer instead of send and call in next slides. But this is the three methods as of now which we have in the Solidity to transfer the ethers basically: send, transfer, and call. So let's go over this one by one. The very first thing is transfer. So transfer is a recommended option which we are saying right now, and this is recommended by all the people, and why we'll talk about in the next slide. But it's a syntax about transfer. So you can see here there are two smart contracts, first and second. So second smart contract is sending some ether to the first smart contract. So what you see here, so we already talked about the fallback functions in the one of the video. In case you haven't gone through the video, I would recommend you to go through that video, which is talk about the fallback functions. So in the first smart contract, what we are doing, we're going to store the balance in the first smart contract. So for that one, what we have defined a fallback function, which is a payable. Okay, if we want the fallback function to accept the ethers, this payable keyword has to be there. If you don't add the payable keyword, it will not be able to accept the ethers. Okay, so this is very important part which you have to keep in mind. So then second function just to get the balance. Okay, so balance is that wherever this contract is deployed, dot balance. So address.balance is a function which we have in Solidity, which you can use to get the balance of the smart contract using the address keyword. So this is your first smart contract. And second contract, what it is doing, it is simply using the transfer function. You can see address.transfer message.value. Whatever value you will send when you call this function, that value will be get transferred and to the first contract, and it will get stored to that smart contract. Okay, so this is the very first option which we have. Now don't worry, in case you don't get the whole syntax here, don't worry for now, because we will show you in the remix IDE this full example, and we'll talk about that how this can work and how this look like. But the question now comes that why we are recommending to go with this option, not the other option. So this method has 2300 gas limits. What it mean actually? So whenever you use this transfer function, this is the only gas limit you are left with. So that you can't do much functionality with this function. This transfer is just going to invoke only one event. It can't do much basically. Okay, so this make it very much secure. So there are some attacks, re-entrancy attacks, which we used to see, which we have seen in the past, and that will safeguard your smart contract. This transfer will safeguard your smart contract from that one. So here there is no possibility to add the gas limit. This is fixed. 2300 is the gas limit which is fixed. You can't change it from your side, and maybe we have in future. So in the future releases of Solidity, we may be able to change this value from our side, but right now this is hardcore value. You can't change this value from your side. And third thing is that this is a very important portion here. Whenever you transfer, use this transfer function, in case it is unsuccessful due to any reason, X, Y, Z reason, what it will do, it will throw an exception, it will revert the state, which is not case with the send and call. So what happened here, you need not to do anything extra from your side. This is an inbuilt functionality which we have with the transfer function. If there is some issue with the syntax or something is not correct in the transfer of ether, then it will automatically throw exception, which you can see in the remix ID as well when we go with the hands-on, and it will show you, okay, that this is unsuccessful and it will throw error. Then it will also revert the state to the initial one. So this is all the features which we have. This is the reason we always recommend to go for transfer. Then there is another option which is send. This is again used to send the ethers here. Again, the first contract remains same. The only difference is that here you can see address.send value. Instead of transfer, you're using a send. But you may have noticed one more thing here. We are using a required. We are using a required function as well. Why we are using, we'll talk about in the next slide. So again, this method also has a gas limit of 2300. And it is also not possible to add the gas limit right now. This is pretty much both the steps are same in the send and transfer. The only difference here between send and transfer is that in case the send is not successful, it is unsuccessful, it will not throw exception, but it will only say you true or false. If it's successful, it will give you the result as true. If this is unsuccessful, it will give you the result as false, but it will not stop the flow, it will not throw an exception, it will not revert your state. So this is the only difference we have between transfer and the send. So this is the reason, just to throw an exception and revert the state, we have to use a required function, which we have to talk about in the error handling. So in case you have missed that one, so you can just go over the session where we have talked about the assert, required, and the revert functionality. So this is the reason the required should be used whenever you use a send function. And third option, which should not be used, this should be your last option in worst case scenarios, but we'll show you that what it all about. In this call function, what we do, this is how the syntax looks like. Address.call value, what value you want to pass, how many ether you want to transfer, then how much gas you want to associate. In the first two options, the gas was fixed 2300. But in this option, you can set the gas at runtime. You can just see it. You can set the gas from your side. We have set is 20317. So this makes this function prone to attacks. So this is the reason we don't recommend for this option. Now if you see here about call, this method supports setting the gas. This does not limit you to 2300. Sometimes people think that this is a feature. No, this is not a feature. This is a drawback, or this makes your smart contract vulnerable to the attacks, because it has more gas limit which you can set, and this can lead to the attacks on your smart contract. So same way as send, in case it is unsuccessful, it will not throw an exception, or it will not revert your state. Rather, it will just show, it will give you the result as true or false. If it's unsuccessful, it will give you a true, false result. If it's successful, it will give you a true back. So out of three options which we talk about, we always recommend to go for transfer, and then second number is send, and then last option should be the call. Okay, so let's see the hands-on here. Let's talk about how this can be used, and we'll go for this option one by one. And let me create one Solidity file here which talk about send ether sample. So what we do here, we go with the same pragma Solidity 0.4.20 here. Again, I will create a correct contract here. So in this one, I'm going to create a first contract, or you can use any other name as you require, but I'm going to create a first here. So this will have, I'm going to create a function here, which is the fallback function. And remember that one, this function should be a payable. In case you don't make it a payable, it will throw an error for you. Okay, so this will help you to accept the ether for this smart contract. Now another function which we created here is the get balance. In case you want to check the balance of this one, just to see whether the functionality is working or not, you can use this one. You can use public returns. This will give you the unsigned integer as a return. Now what it should return? It should return address. This is for this contract. Then balance. Balance is a function which we have inside address. You can use the balance function to get the balance of the smart contract. So you can just see some warning here, that is multiple line spanning, that is okay, and it should be public. It should be showing that it should be public. Let's add a public here keyword. Okay, so this is how it will look like, the first contract. Now I'm going to create a second contract here which will send the money. Okay, I'm going to create a second here. What it will do, I'm going to create a function here like may say send. So I will do one thing here. I will just say this is my public function. So what I will do, first of all, I will just show you the transfer, how you can do a transfer. So you have to just choose transfer here. You have to say message dot value, right? So this is what you have to do. Let me check what is saying that. Yes, so this is again payable. I have to add the payable keyword because this is sending the amount here. Okay, now let's go from starting. Let's first of all compile this one. That is fine. Now first of all we'll do the first smart contract, and then we'll do one thing here. You can see, if first of all let's take the first smart contract. So first of all we need to get balance. So get balance will be shown here. Let me show you here. It will show 0. Currently this smart contract has a 0 balance. Now whosoever will call this fallback function, whatever value that will send to fallback function, it will be get added to the balance. So right now if you see our current value is 0, let me assign 1 ether. I'm going to send 1 ether to this first smart contract. So I will click on this fallback function now. So as soon as you click on fallback function, this 1 ether will be get assigned to this first smart contract. You can click on get balance here. Once you click on get balance, you should be able to see this is in form of WEI V. Okay, so this is how many V we have right now, which is equivalent to 1 ether. Right? So now let's go ahead and deploy the second smart contract also. From that we'll call the first smart contract. Click on deploy. Now you have to take the address of first smart contract, put it in the second smart contract function, and click on send. So once you click on send, okay, currently the value is set to 0. That means you have sent 0 ether. Now if I add this 2 value here, now what I'm saying, I'm sending 2 ether to the first smart contract. Click on send again. Now 2 ether has been sent to the first contract. Now you can click on this get balance function to check the balance of the first smart contract. Click on get balance. So you should see the value got changed to 3. So it was having 1 ether before. Now we send 2 more, it become 3 ether total. Right? So this is how it works, the transfer function worked. Now let me show you the feature which we are talking about. So if you remove this payable from here, right? So let me first of all talk about that one. So we have mentioned in the PPT that transfer is a recommended one, because in case transfer is unsuccessful, it will throw the exception and it will revert the state, right? So let's generate one error here. If I remove payable from this function, then you will not be able to send money to this first smart contract, because this is not a payable right now. So let me first of all deploy the first smart contract, then I will deploy a second. Now whenever I'm going to take the address of the first smart contract and put in the second, now I want to pass 1 ether here. So ideally now this will fail because the fallback function is not payable. Now let's to test this one. Click on send. You can see this is the issue which you have got because your fallback function is not payable. You need not to add any required here or revert statement. This will be taken care by default with the transfer function. You can see the revert started because there is some issue with the transaction here. Transfer is unsuccessful and it got reverted. So this is how transfer works. Okay. So now the second thing which we talk about is about send. Now let me take this back as payable. Now another option is send. Okay, so all things will remain same. Now, okay, you can see it here. Let me show you this thing that this code, this will be ignored, this will be removed going forward. Okay, you can just see this one. Consider using transfer. This is showing you a recommendation. So you should use the transfer instead of send. So let me show you that. Okay, in case you want to go for send only, suppose. Now how this will work. Now same way, first of all you deploy a first smart contract, then second smart contract. Now suppose you want to pass, now I'm going to pass 10 ether suppose, right? I will click on send here. When I click on get balance, it should give me 10 ether. But okay, now you can see 10 ether has been transferred. So this is working successfully. Now, so this is how it can work, simple transfer. Now, suppose I will generate an error now. So what we have talked about in the PPT, what happens with the send, whenever you have this send unsuccessful, this will not throw any exception. This will not revert the state back. Okay, let's see that one, what that really means. Now, click on first, deploy the first smart contract, it got deployed. Deploy second as well. Now what will happen? Let me show you. Now you are going to pass 1 ether suppose. If you click on send now, this will give you no error. Although this is an error condition, but this will not give you any error. Right? If you just see this one, it is showing you execution succeeded. But in reality, this is not true. It got failed, right? So this is the reason we always use require here. That will enforce this to throw an exception in case there is issue. Now, if you try again, if you deploy the second smart contract again, and now let's try again. Now you should see error and reward will be state will be reverted back. I'm going to pass 1 ether here. Click on send. You can just see here transfer has been reverted. Let me show you again. If you click on send, let me show you here. Okay. So first of all, you click on first. Okay, maybe I made the changes here. I have payable. Now first of all, I have to deploy the first smart contract. I have deployed now first. Now let me deploy a second. Now let me clean this up. Now what I will do, I am going to transfer some amount, this here, right? So I'm going to pass 1 ether. So now this should fail. Click on send. You can see this one, this is failing. Transaction has been reverted back because you have used require here. Okay, so this is the difference between send and transfer. Now let's go to the third option, which is call. I will make this change payable again. Remove this one, deploy. Let me make this clean. Now so we'll change this function. Let me do for add. So what we'll do here, add call, and this one dot value. So it should be either you can hardcode or you can just take this value message.value dot gas 20317. Now you can set this value at runtime. Basically you can set from your side, then close this function. Maybe this is not we have mentioned in the PPT, maybe we have missed this to mention this function here. Maybe you can just see that one, you can just see the difference. You have to always use this function in the end from your side. So let's compile this one, and let's first of all do from starting. First of all, you will deploy the first address, first contract, then you will deploy the second one. Now you will take the address from the first and you will copy in the second, and you will pass some ether here. I'm going to pass 1 ether. Click on send. This is showing successfully. Let's check the balance. It should be increased by 1. Yes, this is increased by 1. Now let's generate one error and see how that will behave. I will remove the payable keyword from here, and then I will first of all deploy the first contract again, and second I can deploy again for now, just to test this one. So once I do this one, I will pass these 2 ethers. So now click on send. Ideally what should happen, this should fail because I have to payable, but and let's check the get balance here. First of all, it should not be increased by 2, it should be 1 only. It is assigned to 0 basically. Yes, because this is the 2 value which we have passed, it didn't work, but as you can see, this is showing success. So this is the same issue which we have the send operation. So to fix that one, what you will do, you will use a required keyword here, right? So that you can deploy that again, second contract, and let me clean this up. Let me close this one, deploy second smart contract, take the first address, copy it here, pass 2 ethers. Now it should generate 1 error. You can see. Now with the help of required keyword, you are able to get the error and you are able to revert the state back to the original one. So this is a few options. This is the method. So always remember this one. So I have skipped this to mention in the PPT. So just add this these 2 things in the PPT from your side in the function call, which you can remember for now. But this is 3 options which you have seen just now: transfer and send and the call. So recommendation is go for transfer, not for send and call. And which I remember, I know that this will be get removed from Solidity in the new versions. So transfer is going to stay here. And balance, you can remember for now, this is used to get the balance of the contract or from the address. I'm hopeful that you like this video and this is helpful for you to understand the concept about how to send ether inside Solidity. And thanks for watching.